we will discuss the step turning program. What is step turning? It means, in one workpiece we are creating different diameters. That is called step turning. Next, observe the drawing. It is the final drawing of the step turning component. In this drawing, we will observe the values of the final workpiece, diameters and lengths. In this component, we have 3 diameters and 3 lengths. First, we mention the points of this component. As a graph, points will start the origin of the component. This is the origin. We mention that point is the P1. The next point is the P2 in the x direction. The next point is P3 in the z direction. The next points are P4, P5, P6, and P7, up to the final length of the component. Next, we will discuss the values of these points. The first point is P1. The point value is x0, z0, because the P1 point is the origin of the component. Next, go to the P2 point. We can observe the direction of the P2 point based on the previous point. It is moving in a vertical direction. Vertical direction means x-axis. In that time, we are observing the diameter values because the x-axis is the radial axis. That P2 point value is x30, z0. Because the first diameter is 30 and the diameter starting point, that the z value is 0. The next point is P3. We can observe the direction of the P3 point. It is moving in a horizontal direction. Horizontal direction means z-axis. In that time, we are observing the length values, because the z-axis is the axial axis. The first diameter length is 25 mm. That P3 point value is x30, z-25. The next point is the P4. It is moving in a vertical direction based on the previous point. But we have calculated all values in the origin point. That P4 point value is x60, z-25. Because the second diameter is 60 mm and the diameter starting value is z-25. The next point is the P5. It is moving in a horizontal direction based on the previous point. The second diameter length is 50 mm from the origin. That point value is x60, z-50. The next point is the P6. That point value is x80, z-50. The next point is the final point of the component, that is the P7. That P7 value is x80, z-75. These are the shaper values. Next, program. The program we can divide into 3 parts, in that 3 parts are: first part is the header, second part is the shaper, and third part is the footer. We already know the shaper values. These are the shape values. Now, start the program. We have 2 types of programs. They are roughing program and finishing program. First, we are writing the finishing program. In further sessions, we will discuss the roughing program. Header. G90. It is the absolute dimension data. G71. It is the input of the metric dimension data. Next, select the plane. We are using the ZX plane. That plane activation code is G18. Next, activate the feed code. We have 2 types of feed codes. They are G94, feed in millimeter per minute, and G95, feed in mm per spindle rotation. Next, activate the continuous path code, G64. Next, activate the tool radius cancel code. That is G40. Go to the next block. In that block, we are writing G75, X0, Z0. G75 means a return to the tool turret home position. Next, select the tool based on operation and activate the tool. T01, D1, M06. Next, activate the spindle speed and direction. G96, M03, S150, LIMS equals 2500. Next, the tool safety point. That safety point we are mentioned based on a workpiece. Our workpiece major diameter is 80 millimeters. Above the 80 millimeters we have a safe point. Example 82. The z-axis also maintained a safety point. The safety point value is G00 x82 Z2. Why are we active with the G00 code here? Because that area is a non-cutting area. Next, activate the coolant. That code is M08. Up to now, we are just activating the commands. Next, shaper. Now, the tool is in a safe position. In the next step, the tool is to contact the workpiece. That time, we have to maintain a linear interpolation with slow feed. That code is G01. Start the shaper. We already know shaper values. Those values enter here. First point value is G01, X0, Z0, F0.2. Once activate G01 code and feed rate. That will activate the remaining blocks also. The second point value is X30, Z0. The third point value is X30, Z-25. The fourth point value is X60, Z-25. The fifth point value is X60, Z-50. The sixth point value is X80, Z-50. The last point value is X80, Z-75. Shaper values are completed. Next, footer. The tool returns to the safety point. The value is G00, X82, Z2. Next, stop the spindle and stop the coolant, which codes are M05, M09. Next, the tool turret returns to the home position. That code is G75, X0, Z0. Next, end the program and reset. That code is M30. Next, move on to the software. For these program simulation purposes, double tap on the software. Select the machine. Click on the start. Wait for the controller. Now the controller is opened. Next, adjust the spindle override and feed override. Active the reference mode for machine reference purposes. Next, click on the X plus and Z plus. Go to the Program Manager for new program creation. Click on New. Enter the program name, Step Turning. Click on OK. The new file is open. Once check the program name, stepturning.mpf. MPF is the file format, like .word or .ppt. MPF full form is the main program file. We already discussed one program. That program, enter in this file. N10, G90, G71, G18, G95, G64, G40. Click on Enter. G75, X0, Z0. Click on Enter. T01, D1, M06. Click on Enter. G96, M03, S150. LIMS equals 2500. Click on Enter. G00, X82, Z2. Click on Enter. M08. Click on Enter. G01, X0, Z0, F0.2. Click on Enter. X30, Z0. Click on Enter. X30, Z-25. Click on Enter. X60, Z-25. Click on Enter. X 60. Z minus 50. Click on Enter. X 80. Z minus 50. Click on Enter. X 80. Z minus 75. Click on Enter. G 00. X 82. Z2. Click on Enter. M 05. M 09. Click on Enter. G 75. X 0. Z 0. Click on Enter. M 30. Next, go to Offset for tool checking. It is the turning tool. And these are the geometric values for the tool. This is the tool nose radius. Next, go to the program. Click on Simulation. Activate the auto mode. Click on Reset. Click on Cycle Start. This is the tool path of this program. Next, add the raw material and do one more time simulation. Click on Reset. Next, click on More. Click on Material Removal. In this tab, add the raw material length and diameter. Length is 75 mm. Diameter is 80 mm. Click on Save. Adjust the raw material in the center of the controller display. Next, click on Cycle Start. Go to the controller display and check the values. First diameter is 30 mm. Check that diameter value and check the diameter length also. That diameter is 30 mm. But here it's showing on 15 mm. Because this is the off section, 15 mm is the radial value. The length is minus 25 mm. We are written the finishing program. That's why the tool will be removing the total material in a single time. Suppose we are writing the line program, it takes a lot of time for program creation. In this type of case, we are using CAN cycles. In further sessions discuss the CAN cycles.